Investigation 2.3, filling and wrapping, finding the volume of a rectangular prism. What we have is the ATC toy company is considering using Sabertree's Box Z to ship alphabet blocks. Each block is a 1-inch cube. So we're going to underline that because that's important. So each block is a 1-inch cube. ATC needs to know how many blocks will fit into Box Z. So how many blocks will fit, and the surface area of the box. All right, so that's the first two things that we're going to try to figure out. Now, if you remember, how many blocks will fit into something is basically the volume. So volume equals length times width times height. So in this case, that is going to be 2 times 4 times 10. Now, what I usually tell students is the length and the width, the 2 and the 4, those are interchangeable. Those really depend upon how you're looking at the box. So if you want to say length is 4, width is 2, that's fine. The key thing for this is, given how the box is situated, you have to get the height right. Okay, the other two you can switch up just as long as you label it. So what you'd want to do is say this is height, and I'm going to say this is length, and that's width. All right, when we do this, you will basically get 80. And we have to put our unit of measurement on it, 80 inches cubed. And the reason why it's cubed is because inches, inches, inches. So 3 units of measurement, so therefore it's inches cubed. So now we have our volume. For the surface area, we're going to go back to our formula, 2LW plus 2LH plus 2WH. All right, and since we labeled everything, this shouldn't be too difficult. We are saying 2 times LW is 4 times 2 plus 2 times LH, 2 times 10, plus 2 times WH, which is 4 times 10. All right, so what we're going to get is 16 plus 40 plus 80. And so the surface area for this is going to be 136. Running out of space. All right, 136, and that's inches squared. That is my surface area. All right, so now we have those two things. Now the next thing that we're going to quickly look at is A1, 2, and 3. Okay, so A1 asks us, how many cubes will fit in a single layer at the bottom of this box? So it's telling us that it's 2 by 4. So the way that I try to do this is I try to visualize. There's 2 cubes in the front, and 1, 2, 3, 4 cubes in the back. And if I extend this, so it's a little bit hard for me to draw, but I'm just trying to visually understand what is happening. I can count the cubes, and I can see that I have 8 cubes in the bottom. So now the easiest way to get that is I can see that if I just did 2 times 4, which is the base, that would give me 8. And again, that's 8 inches squared, because it's 2 inches by 4 inches, so I'm basically finding the area of the bottom of the box. All right, so the area of the base will basically tell me how many blocks will fit in the bottom. Now the next question asks us how many identical layers will be stacked in this box. So how many can fit in here? Well, if I look at this, it's 10 inches tall. So just thinking about it, if each block is 1 inch, I can basically fit 10 of them. So it would be 10 layers. Okay, and again, that's going back to where each block is a 1 inch cube. All right. And then question 3, what is the total number of cubes that can be packed in this box? That's basically the volume, which we found out is 80. So we'll just say 80 cubes. All right, and we are all set. So now we basically have all of our information done. Now, what you are going to be doing is you're going to be using this sheet, and you are going to do the exact same thing for box W, X, and Y. One little note, box Y, it left off the height. The height of this is 2 inches. If you look in the book, you'll basically see that, but if you don't have the book, you can basically just look right here, and I want you to do the same thing for box W, X, and Y.